All right, so we're going to be getting another example under our belts here. And for this one, we're looking at a second order DE. Y double prime minus 4y prime equals 6e to the 3t minus 3e to the negative t. And then we have these initial conditions here. So it's the same process. What I want to do is take take a Laplace transform of both sides and use linearity. So we're going to have the not inverse yet. The Laplace transform of y double prime minus 4 times the Laplace transform of y prime equals 6 times the Laplace transform of e to the 3t minus 3 Laplace transform of e to the negative t. Okay. Now, both of these are derivatives. One is a second derivative, and we have formulas that we've developed now for the Laplace transform of a derivative. So this first guy right here is going to, from the formula that we worked out in the previous video, is going to look like s squared y of s minus s, lowercase y of 0, ignore that, minus y prime of 0. Minus 4 times the Laplace transform of y prime, which we know is equal to s y of s minus y of 0. Okay, and again, this is just from that formula that we developed. This is equal to, I can evaluate both of these Laplace transforms using our table. This one becomes 6 over s minus 3, and this is minus 3 over s plus 1. Okay. Now I have some cleanup to do. So there's kind of a lot that's going to go on here, but what I'm going to do is notice that I have y of s showing up in two places. S squared minus 4s. That's going to be showing up right here. Okay? So I'm going to have s squared minus 4s y of s. Now, what else is there? Well, y of 0 is equal to 1. That's one of my initial conditions, so that becomes minus s right there. Y prime of 0 is equal to negative 1. So subtracting that gives me a plus 1 right here. And then here, I've dealt with this term. Y of 0, again, is equal to 1. There's a negative in front of it. Negative 4 times negative 1 gives me positive 4. So that's plus 4 right there. And that's equal to still 6 over s minus 3 over s plus 1. Okay? Now, what I'm going to do is try to isolate this y of s here. So, s squared minus 4s y of s. This would be negative s plus 5. Moving that over, I'm going to get s minus 5 on this side. But one thing I also want to be doing is getting a common denominator with all of this stuff. So notice, actually, let's not do that quite yet. I'm going to have 6 over s minus 3 over s plus 1 plus, let's see, this will be, where are you? Yeah, s minus 5 over s squared minus 4s. Okay? And in fact, what I'm going to do, let's do this differently. I'm going to write this term as s minus 5 over s times s minus 4. Okay? So, what I want to do is get a common denominator with all of this stuff. And, oh, sorry, I jumped ahead of myself. I'm going to do that step over. I've noticed myself doing this before when I'm working from notes. Sometimes I read the step below where I want to be. So let's try this again. I'm going to factor that. This will look like s times s minus 4. I'll factor it there. Times s equals 6 over s minus 3 over s plus 1 plus s minus 5. Okay, sorry. I just needed to move that stuff over. Now I need to divide both sides by this thing to isolate y of s. But I also want to combine all of this into one big rational expression. Now there's going to be a lot of algebra to get to this next step, but I'm going to go like this, dot, 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 because I want to spend not so much time on just the algebra. I would like to get to the important stuff. Okay, so if you combine all of these into one rational expression and divide everything by s times s minus 4, what you end up getting is this, s cubed minus 7s squared plus 10s plus 30, all over this big common denominator of s times s minus 4. I think I put a 3 in my notes, I'll do that one. S minus 4, s plus 1. Okay, and this thing we need a big partial fraction decomposition of. It's going to look like a over s plus b over s minus 3 plus c over s minus 4 plus d over s plus 1. Okay, now this is a big partial fraction decomposition, and there's a lot of steps, but it's actually fairly straightforward. You know, same thing as always, you multiply both sides by that common denominator here to clear all of these denominators, and then you plug things in to solve for those unknowns. Because we've already done a couple of examples after partial fractions, I am going to skip showing that, but I encourage you to try and fill in in your own notes the steps that would go here, because you're going to need that practice. We're going to end up with this. Y of s is equal to, a would be 5 halves. So we get 5 halves over s. B ends up being negative 2, so I get minus 2 over s minus 3. C ends up being 11 tenths, so I get plus 11 tenths over s minus 4. D ends up being negative 3/5, so I get minus 3/5 over s plus 1. That means y is equal to the inverse Laplace transform of that y of s, just like before, and each of these Laplace transforms we can evaluate directly. I can take the 5 halves out, I get 1 over s. The inverse Laplace transform of that is just 1, so 5 halves times 1 is 5 halves. Then I'm going to get minus 2 e to the 3t from that guy, plus 11 tenths e to the 4t from that guy, minus 3/5 e to the negative t from that guy. And this right here is my solution. Okay? Again, I did skip a lot of the algebra and the partial fractions here just because we've done that a couple of times already, and you should know that process. But this is the idea, and that wraps up 7.2.